We start by introducing the concept of systems architecting. Jones sees the need for a first step called systems architecting in the process of the design of a system. He then sees the twin engineering processes of systems engineering and design engineering involved in the remainder of the design process. Blanchard prefers to see the whole as systems engineering. We will on the next slide refer back to part of figure 1.8 encountered in the introduction of this session. Blanchard specifically includes both blocks 2 and 3 in the diagram above into his definition of systems engineering, but excludes systems architecting. He starts with a conceptual design, which assumes that you already know what the total need is. He thus starts with the possible routes towards solving the perceived functional need. Nevertheless, the perceived need may be wrong if there is no systems architecting phase. Of course, Blanchard may see that as part of the conceptual design, but he does not say so. In all design endeavors, one first have to determine the boundaries of the resultant design. This role is performed by the systems architecting process. It stretches the design process to make use of all these qualities: insights, vision, intuition, judgment, feelings, and taste. It is the best method for creating exceptional new systems. It is just the fact that designing without proper design limits can overload the design process. The designer can be totally swamped. The solution is to have clear goals up front. It can delay the design process past bearing. Also, there are many unquantifiable circumstances that needs to be taken into account of in the design. These include politics, the environment, public opinion, perceptions, realities, safety, security, affordability, and value for money. All of these must be evaluated well before proceeding with the design. Safety is naturally critically important. Another related issue is security. And then there is the need for affordability. This includes what to include, or more importantly, what to exclude from the design. Think about the value that the user will get. That is, what does the user get and at what price? Many of these matters are intangible, but are nonetheless important. Systems architecting methodologies. First, determine system boundaries using accepted engineering standards. Analyze. Get wide participation from everyone involved. Use heuristic methods to enhance the above-mentioned methods. Some examples of heuristics that may be used, sometimes with excellent results. Simplicity. Think about what can go wrong. Question the premise. Beware of overcomplication. Beware of first-day mistakes. Be cautious of models created to prove the concept. Part of the importance of systems architecting process is that it should attempt to reduce system complexity to the absolute essentials. It is clear from the figure that the functional relationships of systems increases exponentially as the number of functions increase. A 3-function system has 9 functional relationships against 4 for 2 functions and 1 for 1 function. The architecting process determines the system's parameters, including the limits or boundaries of the design, and thus the goals, thresholds, and constraints by which the system engineering process must abide. It is very easy to overspecify the system. One must beware to include parameters that are even unacceptable or undesirable. The architecting process should specify only those qualities that are mandatory and those that are really desirable. Remember, less is better. So what must system engineering then do? It must implement the system's definition provided by the architecting process. It needs to establish measures that can be used to gauge success. It defines the system such that the designer and the producer know exactly what to do. It integrates the system with other systems that it needs to work with. It needs to evaluate the success of the system. The following is the system development cycle presented by Jones. It shows the full cycle starting with the definition of need. This is where systems architecting operates, and then moves through the 3 systems engineering phases to the manufacture and use of the system. Blanchard has an equivalent diagram which is repeated twice in his book, figures 4.2 and 6.1. The diagram is somewhat different as it portrays the life cycle more using the detail of the process rather than the systems engineering design steps, which is covered in most of its other figures, including figure 1.8, which we revisited in the introduction to this session. Here we see the first step of the systems engineering process as per Jones, that is conceptual design. It includes the development of requirements, setting targets for system availability, developing the various concepts including the maintenance and support concepts, setting various targets, looking at interoperability, and making sure that the design will result in minimum operational cost. The second step in the systems engineering process is preliminary design. It includes functional analysis and a number of supportability engineering refinements and improvements. This is the functional analysis process block diagram breakdown that we encountered before. And this is Blanchard's equivalent. And here we have a short description of the detailed design phase. Here the final product is given body. The outputs of this process include operational availability, final lifecycle cost, the requirements for system maintenance, resources needed for support, and personnel needed for operation and support. And then the production and delivery. This concerns the provision of a proper support package, including providing all the necessary resources, providing performance and cost benchmarks, establishing the support capability, assessing the success of all design changes, and plan the field assessment process. And in-service sustainment. This includes upgrades, planning for the next generation system. All of this is done through post-delivery assessment, in-service data collection, trend analysis, design change assessment, and modification planning. This then ends session 2A on systems architecting.